Not since Galileo invented the telescope over 400 years ago has our view of the universe been so transformed. In April 1990, astronauts stationed the Hubble Space Telescope in orbit, above the blurring effects of Earth's atmosphere. It returned scenes of unprecedented beauty, as well as clear, sharp images of a dynamic, changing universe. Stars, planets, galaxies, each evolving in time from birth to dissipation and death. This portrait of a universe in motion is Hubble's enduring legacy. The Hubble Space Telescope is now regarded as one of the most revolutionary scientific instruments ever built. While not the only telescope launched into orbit, it has surely been the most versatile. Spacewalking astronauts returned 4 times to upgrade its instruments to newer and more powerful technologies. As a result, Hubble has been able to probe the life cycle of stars. From their birth in nurseries of dust-laden clouds of gas, all the way to their final farewell as delicate nebulae slowly blown into space. Or as titanic supernova explosions that outshine their host galaxies. Hubble has peered into the breeding grounds of new solar systems. Dusty disks around newborn stars that may condense into planets. And it has transported us into the billions of galaxies that spread out across the depths of time and space. One of the most photogenic galaxies is a grand spiral called M74, located about 32 million light-years from Earth. Amateur astronomers have long known it as the Phantom Galaxy because of its low surface brightness. Hubble astronomers, on the other hand, saw spiral arms laced with delicate tendrils of dust silhouetted against bright ribbons of stars. These spiral arms are not like spokes on a wheel. They are density waves that move around the galaxy, compressing gas and stimulating the birth of vast waves of new stars. Using Hubble, astronomers are uncovering fascinating details within galaxies they once considered featureless and bland. NGC 1132 is an immense ball of stars some 320 million light-years away. Astronomers have concluded that this giant is the product of a gravitational feeding frenzy. Hubble showed that its surroundings are dotted with dense clusters of stars. They are what's left of galaxies that were swallowed by 1132. How galaxies grow and evolve over time is an enduring mystery that Hubble astronomers have sought to unravel. The first galaxies are thought to have formed out of clumps of gas in the early universe. These proto-galaxies came together to form larger and larger galaxies. Such galactic mergers may play out over hundreds of millions of years. Hubble has shown that it is an elegant waltz of stars and gas, choreographed by gravity on a grand cosmic stage. As the galaxies pass each other, their gravity pulls stars and gas into the space between them, building vast, luminous bridges stretching tens of thousands of light years. As the galaxies fall together again, long streams of gas and dust, known as tidal tails, wrap around their disrupted shapes. As the galaxy cores approach each other, the gas and dust clouds that envelop them can be dramatically accelerated. This results in shock waves that ripple through interstellar clouds, setting off bursts of star formation that appear as brilliant blue knots. Gravity is not the only force that can tear a galaxy apart. Hubble spotted a spiral galaxy plowing through a cluster of galaxies. There, it has encountered a vast cloud of superheated gas. Drag from this cloud is stripping away gas from the galaxy, creating tattered threads and blue tendrils. It's also pulling away streams of murky dust, as shown by the dark brown tangled region around the galaxy's center. When Hubble observations are combined with X-ray images, a bright extended fog can be seen enveloping the galaxy and streaming off into space. In the end, this encounter will leave the galaxy with very little gas and almost no chance of forming any new stars. Galaxy collisions are not always destructive. Take the case of Centaurus A, 32 million light-years from Earth. Shock waves produced by a collision have sparked an intense round of star formation, as seen in the red patches visible here. The turmoil of the collision explains the warped shape of the galaxy's disk, as seen in this wide view from a ground-based telescope. There is something else about Centaurus A that stands out. Using radio and X-ray telescopes, astronomers have spotted powerful jets blasting out of its center, and broad plumes of matter racing far beyond the galaxy. Where is all that energy coming from? Answering that question has become a major focus of Hubble observations since the day it was launched. Astronomers had long noticed that the centers of large galaxies are unusually bright. They speculated that there must be some kind of massive object lurking there. Could these objects be dense collections of stars? Or are they a breed of supermassive black holes? Millions or even billions of times the mass of our Sun. Hubble's search for the answer began in the center of a giant nearby galaxy, M87. Astronomers saw that its color was not quite the same on both sides. One side was shifted towards blue, and the other towards red, a hint that it must be rotating very quickly. This is because the wavelength of light is changed by the motion of whatever is emitting it. This is also known towards you. The wavelength of its light gets squashed, making it appear bluer. If the object is moving away, its light gets stretched, making it redder. By measuring how much the colors had shifted from one side of the disk to the other, astronomers were able to determine its speed of rotation. It turned out that this disk was spinning at a rate of hundreds of kilometers per second. Astronomers concluded that an object must be lurking in its center that's at least 4 billion times the mass of our Sun, a supermassive black hole. This was a key piece of evidence in the discovery that supermassive black holes occupy the centers of most, if not all, large galaxies, including our own Milky Way.